Lesson 100, we are continuing learning how we graph parabolas. Today we will be doing them by completing the square to get them into vertex formula. The examples today are the same as on your small handout that says Lesson 100, Part 2, Graphing Parabolas at the top. Our first example is strictly review. So if we look at that, we know that the number in front there is positive, which tells us that the graph opens up. We also look at it and we can get the vertex by taking the opposite of the number that is inside the parentheses and the same as what is outside. So that would be positive 1, negative 2. The axis of symmetry must have the x equals as part of the equation, and it is always the first coordinate of the vertex. So let's graph that much and see where we are. So here is our 1, negative 2. So we have our vertex there. We know that it opens up. Our axis of symmetry goes through that vertex. To get the y-intercept, I know it's already labeled on this graph, but let's show the work of how we get it. We let x be equal to 0, because remember, when something crosses the y-axis, we go left and right 0, so we know the first coordinate is 0. We plug that in, and y has to be 0 minus 1 squared minus 2. Negative 1 squared is 1. Minus 2 gives us the negative 1 that we see there. So our y-intercept is 0, negative 1. We see that we have 2 x-intercepts. Because it opens up, it must cross that x-axis twice, which tells us that the discriminant must be positive. Since we have 2 real numbers that we can plot on that horizontal axis, the square root in the quadratic formula would have to be square root of a positive number. To actually find what those x-intercepts are, now we need to let y be equal to 0 and solve for x. So we have 0 equals x minus 1 squared minus 2, but I'm going to put it over here on the right as a plus 2, so that then I can get rid of my square by taking my plus or minus square root of 2 when I take the square roots of both sides. So now I have x minus 1 is plus or minus the square root of 2. So x is, if I add the 1 now to both sides, plus or minus the square root of 2. I need to always write these as 2 separate points with ordered pairs, both coordinates in there. So one of them, the one on the left, was 1 minus root 2 comma 0, and the one on the right would be 1 plus root 2 comma 0. Not required, but I know which one is left and which one is right, because if I take 1 and subtract something, I get a smaller number than if I take 1 and add something. That would make me go farther to the right. I need to always plot 5 points when I am doing these, so I had 0, 1. By symmetry, on the other side of the axis, I have that point. It happens to be 2, negative 1. I need to get something else in there. So I already have ones with x coordinates 0, 1, and 2. So I'm going to plug in negative 1 just to get a third point. So I go back to my original equation, and y has to be negative 1 minus 1, that's minus 2 squared, and then subtract 2 more. So I have 4 minus 2, which is 2, which gives me this point right here. If I go to my axis of symmetry and go 2 more on the other side, I have the other point. Draw my nice parabola through all 5 of those, and we always put arrows on both ends to remind us that the parabolas keep going forever. So now that we've reviewed that, let's continue on with a new one. Now this time we need to complete the square in order to graph this parabola. So when we want to complete the square, it's very much what we've done before when we've completed the square to solve equations. We're still going to keep the x's on one side, x squared minus 6x, and we're going to figure out what we need there to complete that square, and we're going to have everything on the other side. It's now not going to be just a number, we're still going to have the y and then a minus 2. So as we did before, we take half of the minus 6, so we have minus 3, and we put that in the parentheses. We square that, and then we mentally FOIL out x minus 3 times x minus 3, and we have x squared minus 6x plus 9. We took this 3 and we squared it to get that 9. But if we add 9 on the right, we know that we need to add 9 on the left, giving us y plus 7 equals x minus 3 all squared. So now bring the 7 over to the other side, and now it is in my vertex form, x minus 3 squared minus 7. So that tells me this is positive, so it opens up. It tells me my vertex is the opposite of the negative 3, so a plus 3, and the same as what I had outside the parentheses. So my vertex is 3 minus 7. That means my axis will have to go through that point, so it will be x equals 3. My y-intercept. Now the easiest place to go for your y-intercept is back to the very original equation and plug in 0. It's very easy to look at it. 0 squared minus 6 times 0, that's all 0, so it's just a 2. It's kind of like slope-intercept form, y equals mx plus b, the number that isn't with any of the x's, that's by itself. When it is not in vertex form, is 0, 2. So there's a little bit of a trade-off. If you have to go to the extra work of completing the square to get vertex form, then it's easier to get the y-intercept. If it's already in vertex form, then it's more work to get the y-intercept. The other thing that we need is we need our x-intercepts. Now for this one, the easiest place is going to be this equation where we had the parentheses squared on the right, but we had the y plus 7 on the left. So what I'm going to do with that is I'm going to let now y is 0, so I'm going to have 0 plus 7, or just 7 equals, and then on the right, I need to find what x is. I don't know it, so it is still x minus 3 squared. Now when I take plus or minus square root so that I get rid of that square root sign on the right, I have x minus 3 is plus or minus 7. And then if I add the 3 to both sides, I know that my x-intercepts have to be 3 minus, it should be root 7, comma 0, and 3 plus root 7, comma 0. I also know, let's go ahead and plot what we see so far. So, as we said, the vertex is 3, negative 7. Y-intercept is 0, 2. We will draw our dotted axis of symmetry here. So from 0, 2, we went 1, 2, 3, 1, 2, 3, and we got this symmetric point. We have it opening up. Our x-intercepts 3 minus root 7, 3 plus root 7, comma 0, you would not actually be writing these on your graph in then decimal form or even needing to write them with the square root there. But if you punch 3 minus root 7 into your calculator, you would get that 0.354 that you see, and 3 plus root 7 would give you the other decimal that you saw up here. We notice, though, that since we have two x-intercepts, that means the discriminant must be positive. And we still need two other symmetric points for things that we might plot on our graph. So I'm going to see what happens if I plug in, let's try 1 for x. 1 squared is 1, minus 6 times 1 plus 2 would give us negative 3. So we have 1, negative 3, and then by symmetry we also have this point. Then we have our nice beautiful parabola with our arrows on both ends, and we have answered all of the questions for that one. Example 3 now on your papers. We need to complete the square once more with this. And again, we're going to get everything without an x on one side, so that becomes y minus 2. And we're going to have all of the x's on the other side. We know we want to complete the square, so we have a parentheses that begins with x. And we're going to end up needing to add something out there on the right to make that be a completed square. A little bit harder on this one. When we take half of the plus 3, we have plus 3 halves. I recommend leave this in decimal form. It is going to be much easier than trying to do it in a decimal form. When we square that, we get 3 over 2 squared, which gives us 9/4 that we have to add to both sides. Now 9/4 is 2 1/4, so if we subtract 2 from that, we have y plus 1/4 equals x plus 3 halves all squared. Subtract the 1/4 on both sides, and we have our vertex form. X plus 3 halves squared minus 1/4. Again, it's positive in front of the parentheses, so it opens up. The vertex has to be the opposite of what's inside the parentheses, so negative 3 halves, and the same as what is on the outside, so negative 1/4. The axis has to be x equals the first coordinate of the vertex, so minus 3 halves. To get our y-intercept, we go back to the original equation, and we plug 0 in for x. So we have 0 plus 0 plus 2, and our y-intercept is 0, 2. For our x-intercept, we are going to go back to the equation where we had y plus 1/4 out there in front. So we're going to let y be 0. So 0 plus 1/4 is 1/4. That needs to equal x plus 3 halves squared. To get rid of the square, we take the square root of both sides, but we know that we need a plus or minus in front. Square root of 1/4 of any fraction is square root numerator over square root of denominator. So square root of 1 is 1, square root of 4 is 2. And then I have my x plus 3 halves here. Now I am going to subtract that 3 halves from both sides, so it's minus 3 halves. Since they are rational numbers, I do have to combine them. Minus 3 halves minus 1/2 is minus 4 halves, or negative 2. Minus 3 halves plus 1/2 is negative 2 over 2, or negative 1. Those are my x's for the x-intercept, so the points are negative 2, 0, and negative 1, 0. We've got some nice fractions instead of those messy square roots. Since we have 2 of them, we know that once again, our discriminant has to be positive. Where was it? Negative 3 halves, or negative 1 1/2, negative a fourth. The calculator graph automatically did decimals on those. We have our x-intercept. Our x-intercepts are negative 2, 0 and negative 1, 0. We have our y-intercept is 0, 2. And if I draw my axis of symmetry in here, I can, by symmetry, come the same distance on the other side and have my fifth point, draw my parabola through those, and get my arrows on both ends. Okay, next one's going to have a little bit different twist to it, so I want you to be really careful and pay attention as we do these next couple of them. If you look at that, the one thing that's different is we have that minus sign in front there. So what I am going to do, I am still going to bring everything that is not an x over to the right. So I have y plus 3 equals, and that means I then have just the x's on the right. But if it does not start with 1x squared, I need to factor out whatever's in front of that x squared. So in this case, I need to factor out a minus 1 times the x squared. But if I take a minus 1 out of the minus x squared, I need to take it out of the minus 4x also. So this becomes a 4x. And so just then a little quick double check before we go on. Distribute the minus 1, and do I have what I started with? Minus x squared, minus 4x. Yep, that's what I needed to have. Then minus 1 needs to be times a whole parenthesis, so I need a right-hand side on that parenthesis, but I'm going to leave enough room in there to complete the square on it. So on my next line, I keep the minus 1 out in front, and then I take half of what is now a plus 4, so I have a plus 2, and square that. If I take x plus 2 times x plus 2 and FOIL it, I get x squared plus 4x plus 4 that I need to write inside my parentheses. But I have to be careful. That is not really a plus 4, it is really a plus 4 that gets multiplied by a negative 1. So it is really a minus 4 that I just did on the right-hand side. So I have to do a minus 4 over here on the left-hand side to match that. So what that leaves me with is y minus 1 over here. So now my vertex form is y equals negative 1 times the x plus 2 squared, and then when I bring it over on the right, a plus 1. So this tells me that it opens down. The vertex is the opposite of what's on the inside of the parentheses, same as what's outside the parentheses, so the vertex is negative 2, positive 1. The axis of symmetry has to go through the x-coordinate of the vertex, so x equals negative 2. To get my y-intercept, I still go back up to my very original equation, put 0 in, and I have minus 0, that's just 0. So when x is 0, I have only minus 3 left. In order to get my x-intercepts, now I go back to this equation where I had y with a number on the left, and I have 0 minus 1, which is just minus 1, equals, and then I have a minus x plus 2 all squared. When you have a minus in there, the easiest thing to do before you try to take square roots is to multiply both sides by a minus 1 so that we get rid of our minus signs, and we are now looking at 1 equals x plus 2 squared. Get rid of the square by taking the square root. but make it be a plus or minus. Square root of 1 is just 1. So if I have x plus 2 is plus or minus 1, subtract the 2 from both sides, and my x-intercepts are negative 2 minus 1 is negative 3. Negative 2 plus 1 is negative 1. I have 2 of them, so that's also going to tell me that my discriminant is positive. And let's see if that is indeed how we would draw the graph here. So it has a vertex of negative 2, 1. That matches. It does open down. Our axis is the vertical line that goes through the vertex, x equals negative 2. Our 2 x-intercepts, negative 3, 0, and negative 1, 0. Our y-intercept, 0, negative 3. And then by symmetry, 2 on the other side, we have this 5th point. I'll draw the parabola through all of those, and arrows on both ends. Okay, a couple more. This next one is going to be similar to what we just did. Once again, we've got that minus sign in front. So we are going to get everything without an x on the left, so it now becomes y minus 1. On the right, we need to factor out whatever is in front of the x squared so that we can begin our parentheses with 1x squared. If we factor the minus 1 out of the minus x squared, we factor it out of the minus 5x, so we have a plus 5x, and we leave room inside our parentheses for whatever it is that we need to add. So we keep the minus sign in front of the parentheses. We take half of the plus 5, which is plus 5 halves, and that's what we need to square. To go in here, we need 5 halves times 5 halves, which is 25 fourths, 6 1/4. But it is not really a plus 25 fourths. It is really a plus 25 fourths that got multiplied by this minus sign out in front. So it really was a minus 25 fourths. So we minus 25 fourths on the left as well. Minus 1 is minus 4 fourths. So if we put that together with minus 25 fourths, we have y minus 29 fourths. So we get a little bit messy vertex going on here. When we get it in vertex form, we have y equals minus x plus 5 halves squared plus 29 fourths. So we have another parabola that opens down. The vertex is the opposite of the number in the parentheses, so minus 5 halves, the same as what's on the outside. Our axis of symmetry is going to be x equals the x-coordinate of the vertex, so x equals minus 5 halves. For the y-intercept, we go back to that original equation, and we let x be 0, and if we do that, we get x was 0, 0 minus 0 plus 1, we get 0, 1 for the y-intercept. I'm not going to actually find the x-intercepts in the interest of time, and just because I would be so messy on this problem, but let's take a look at what we have so far. So we have the vertex, negative 5 halves, that's the same as negative 2 1/2. 29 fourths, that's 7 1/4, so that looks right here on the graph. The y-intercept is 0, 1. If we put in our axis of symmetry going through this negative 2 1/2 right here, if we go 2 1/2 to the left and then 2 1/2 more to the left, we have this symmetric point. Since it opens down, we can simply look at the graph and say, you know, we have 2 x-intercepts. Because we have 2 x-intercepts, that discriminant had to be positive, even though I did not find the coordinates of those x-intercepts. And that brings us to our last example of the day. And now we have something besides just a minus sign in front of that x squared. So, like we did before, we get everything without an x on the left. So y minus 3 equals, and then we're going to complete the square with the x parts. But we need our parentheses to always begin with 1x squared before we try to complete a square. So that means we need to factor out 2 this time. If I factor out a positive 2, that leaves me a minus 4x. And remember to leave space and then close the parentheses. So now I keep the 2 in front. I take half of the minus 4, which is a minus 2, and then I'm going to square that. If I FOIL out x minus 2 times x minus 2, I have x squared minus 4x plus 4. But it is not really...
Mr. Willie, to the main office, please. Mr. Willie.
It is not really a plus 4. It is really a plus 4 that gets multiplied by a 2. This side, we have y plus 5. So to get it in its actual vertex form, subtract the 5 on both sides, and I have 2, x minus 2 all squared, and then I have that minus 5 on the end. The 2 is positive, so it opens up. The vertex is the opposite of what is inside the parentheses, so a 2, and the same as the number on the outside, so minus 5. The axis is always, don't forget the x equals, and then the x coordinate of the vertex. Y-intercept, we go back up to our original equation and put a 0 in it, so we have 0 minus 0 plus 3, so we have 0, 3 for that. To get the x-intercepts, I take my equation where I have the y with a number, and that one's going to get a little bit messy to do it that way. I'll tell you what might be an easier way on this one. To get the x-intercepts, in this case, y is going to be 0. So I'm going to model another way that we could do this. This time, I'm going to take that original equation again, and if y is 0, I have 0 equals 2x squared minus 8x plus 3. Hey, that equals 0. I can use my quadratic formula. I can say that x would have to be the opposite of b, so that would be positive 8, plus or minus the square root of b squared would be negative 8 times negative 8 would be positive 64, minus 4 times a is 2, times c is 3, and that is all over 2a, so 2 times 2 would be 4, so I have 8 plus or minus 64 minus 24 would give me the square root of 40, and that's all over 4, so I'd have 8 plus or minus square root of 4 times square root of 10, so 2 times the square root of 10 over 4. And then when I have enough room that I can scroll down, I'll write that as 2 plus or minus root 10 over 2 to finish simplifying it. But let's see what our graph is looking like at this point. So we have our vertex 2, negative 5 down here at the bottom. We have our axis going through that vertex, so the line x equals 2. We have our y-intercept 0, 3. Go 2 to get to the axis, 2 more, and we have a symmetric point there. We've got 2 x-intercepts showing up there. They're just a little bit hard to know what they are or exactly where to plot them. As I said, if I finish simplifying this, I'd have 8 over 4 would be 2, plus or minus 2 over 4 would simplify to a half, so root 10 over 2. So my 2 x-intercepts would be 2 minus root 10 over 2, comma 0. and 2 plus root 10 over 2, comma 0. To get my 5 points for really drawing the graph, I would do an XY table, and maybe I pick 1, since I know the vertex is at 2, and I know the y-intercept, so let's pick 1 for x and plug it in, and I would have original equation y equals 2x squared minus 8x plus 3, so 2 times 1 minus 8 times 1 plus 3 would give me 5 minus 8 would be negative 3, so I have the point 1, negative 3, and then the fifth point by symmetry. So, did a bunch of examples there. Hopefully that is letting everything sink in for how this works with completing the square to get the vertex form, and then all of the steps that we require as you show your graphs for that. I want you now to be working on your problem set paper that says 100B up at the top. The back of it is problems like this, and we've given you the prompts to help you remember all of the things that you need to fill in. Parabola, up or down, the vertex, the y-intercept, the x-intercepts, whether the discriminant is positive or negative. Although I guess I never did say that on this last one, did I? So I'll add that in. 2 x-intercepts, discriminant is positive. Remember, if you have no x-intercepts, that means your discriminant was negative. If the vertex is the one and only x-intercept, then your discriminant was 0. Right, time for you guys to get to work on your homework problems.